So finally, you have all of these features, components integrated in your vehicle. For simpler builds, you can actually integrate these in directly to indicators and also your contactors. Once it gets a little more complicated, you're going to see that you have some type of vehicle control unit or a supervisor or some type of hardware and software that is controlling and monitoring all these systems. And this vehicle control unit, one of its main roles is to start up the car correctly, shut down, but also keep you safe. VCU may control contactors, control your pre-charge and discharge, pedal to torque request mapping to the motor. It'll monitor your HVAL like we talked about and control all your high voltage components. It should always be monitoring, it should always be reporting, and most importantly, it's always acting on these faults. If a fault happens, depending on the severity, what should the VCU do? A BMS could do this job. The name doesn't really matter. You just have some type of hardware or software that's playing this safety role. For isolation, a VCU will, when you turn on the vehicle, the VCU will continuously monitor what isolation is. And then it'll check, hey, are you above this magic value of 500 ohms per volt? In our vehicle, we have a warning if it drops below 1,000. Normal for us in our kit is like 10,000 ohms per volt. If it drops below 1,000, there might be an issue. We'll set a lamp to tell the user. We'll start reducing power a little bit. And then most importantly, we'll actually log the fault and set a DTC. So you can actually read the trouble code after the fact, and you don't have to know it's happening right then and there. You can actually see that it happened after your drive. Now, if that isolation starts dropping too low and it gets below that, the next action is you still set that lamp, but now you need to shut down high voltage, and you need to do it safely, not while you're going 60 down the highway. Just an example, here's the OBD2 faults in our vehicle to signify that this happened. For HVAL, it's a similar thing. Start up the vehicle, the very first thing we do is we check HVAL. If HVAL is not good, we don't have everything plugged in, we're not going to start up the car. If that happens, we'll set a lamp. We'll prevent contactors from closing so no high voltage gets onto the bus, and then we'll log this fault. Going to thermal management, when you're, for instance, in this example, it's batteries, but it's the same thing for inverters, the same thing for motor. The VCU will continuously monitor those temperatures. For example, if our batteries get above 50 degrees C, which they shouldn't, we'll start maxing out our pump and fan to try to get as much cooling as possible. Once we get a few degrees higher, we start reducing power to try to prevent the batteries getting any hotter, but still letting the vehicle drive. And if for some reason the temperature gets above 55 C, then we take the most extreme action where we set the lamp. We tell the user it's overheating. We shut down the vehicle when it gets into a safe state. Similar for discharge. So this is mainly on shutdown. Most of the time when you shut down on our system, because we have active discharge, you know that no high voltage is present. But if that high voltage discharge were to fail, the user needs to know so that they don't go disconnecting high voltage cables expecting there to be no high voltage.